Welcome to my YouTube channel Kadam Academy, PGK Kadam Academy. Dear friend, this video you can learn vibration shakers, exciters, their construction, principle, working and where it is used. Dear friend, you can see the shakers and exciters are great tool devices are to provide what to control or measurable vibration input to the test object or the structure. We can give the excitation by the using these exciters or the shakers. The cyclic excitation force produced by exciter can be applied to that machine or structure so as to study its dynamic characteristics. Dear friends, what will happen when generate the specified range of the displacement and harmonic time dependent excitation force across the certain frequency range? We can test it before that product we are going to launch. Dear friend, there are three major types of the vibration exciters. First is the mechanical exciters, electrodynamic exciter, and hydraulic or pneumatic exciters are available in the market. These mechanical exciters, when we study, there are two types: Koch-Yoke mechanism and the two rotating masses. They are again divided depend on their mechanisms. Dear friend, this Koch-Yoke mechanism, when we study, this is the mechanical exciter. This Koch-Yoke mechanism can be used to produce the harmonic excitation force. You can see here harmonic force F is there with the formula F is equal to m omega square r sin omega t. Already I studied. You can watch the video in the single degree of freedom, undamped, damped vibration, and the force vibration videos are available on the playlist. You can go through the playlist. You can watch the video of the theory. In the system, what will happen? The crank mechanism is there. That is rotating with a constant speed or variable speed by the motor. The other end of the crank slides in the slotted rod, which reciprocate in the vertical guide, and the harmonic force that can be applied on the structure by the exciter, and that will be F. And you can calculate the F, m omega square r sin omega t. M is the rotating unbalanced mass, that omega is the crank speed radian per second, r is the radius of crank. Here what will happen, this type of the Koch-Yoke mechanism is nothing but the inversion of double slider crank mechanism. The next type of the mechanical exciter is the two rotating masses. This also is the one of the mechanical exciter. You can see here the two rotating masses are there that will create the excitation force on the structure. The specification of these mechanical exciters are there: frequency up to 50 Hz and displacements up to 2.5 centimeter, maximum force up to 4,500 Newton, and it will create only the sinusoidal excitation waveforms. Friends, here is the two types of these are we're going to study: the electrodynamic exciter or shakers. Hydraulic or pneumatic exciters are there, or the electrodynamic exciters are there. In electrodynamic exciter, the shakers, wide frequency it is there from 5 Hz to 10,000 Hz it can create. The displacement up to 7.5 centimeter we can create by using this type of the electrodynamic exciters. What will happen in this actual construction will go in detail. These that will create the excitation in X direction, in Y direction, in also Z direction. These type of the electrodynamic exciters are having the four major parts. The amplifier, which will amplify the signals, and the actuator, which will create the acceleration on the structure or the component which you are to test, and the controller that will be having in CPU will get all the readings and will get the graphs, and we can store the data whatever we are recorded. And this is the sleep table for useful for the creating the X and Y direction axis directions. This accelerometer you can see on the top of the actuator that will receive the signals of acceleration and the frequency from this electrodynamic exciter. This electrodynamic exciter or the shaker, which is also known as electromagnetic exciter. Why? Because this electromagnetic exciter are work on the electromagnetic principle. This electrodynamic force is applied to vibratory structure. On the top of the exciter table here you can see that force is applied on the top of the magnitude of acceleration of the component depend on maximum current and masses of component and the moving element on the top of this. The working principle of the electromagnetic field already you know. Here is the rule you can see here that F is equal to LIB is the formula through this coil. You can see here these are the coils. The coils are there surrounding to this the exciter table, and surrounding this coil there is a magnet is there, permanent magnets. Through this coil when current passes, what will happen? Force is developed on the due to this current carrying wire, and that force is nothing but the proportionate with this current carrying coil, and the V magnetic flux in Weber per meter square, and L is the length of coil meter. As this will increase, we can increase the force also. So friends, what will happen here? The small shakers use the permanent magnets, and the mid and large shakers use the field coil for the electromagnetic field, generating the force. These are the different shakers over time. They are available in the market. The spacecraft is shaken on the vibrating table or subjected to pyrotechnic shock to replicate the conditions during the launch. Hydraulic pneumatic exciters. These are again fluid pressure is used here, and the mechanical and electrodynamic exciters already were studied. Generally, they are used for the limited force, but the limited frequency range is there. When the exciters to be used for the larger force, the capacity, the wider frequency range, the hydraulic and pneumatic exciters are used in industry. These are mostly preferred exciters. Here you can see the block diagram. Here in this arrangement, electrically actuated servo valve is there. This is the servo valve which is electrically operated, and that will actuate main control valve, and that will create the excitation. Hydraulic excitation in case of the oil is used. When there is the air, that pneumatic exciter it is called. So these are the detailed instruction, and the exciting force that will near about 4000 hertz it will create, and the maximum load we can see here. The larger displacement 50 centimeter, 200 hertz can limited frequency below the 200 hertz, and 4,50,000 Newton maximum force we can create by using this hydraulic or pneumatic exciters or shakers. So friend, if you are not subscribed, share my channel, and not like, please like, share and subscribe my channel. Thank you very much.